So in the previous video, we looked at linear transformations of random variables. This time, we're going to combine two different random variables together and see what happens to our mean, or measures of center, and our standard deviation, or our measures of spread. So we've got Pete's Jeep Tours. Let's say he's got a sister across the other side of the country, and she runs a company called Aaron's Adventures. And y is going to be the random variable associated with the number of passengers on a randomly selected trip with Aaron and her adventures. T is going to be defined as the sum of the number of passengers for Pete and the number of passengers for Aaron. We want to know what the mean and variance of this new random variable T is. Let's say Aaron and Pete's dad want to know how they're doing. So he's going to crunch some numbers on their two businesses and look at what the average and spread is for their passengers. So here is Pete, random variable of x. There's our possible values. Here's our probabilities. There's our histogram. Here's y. Here's Aaron's adventures. Number of passengers. She can only carry 5 passengers. She can't carry 6. Here's our probabilities, mean, standard deviation. There's our histogram. So really the question is, how many total passengers can they expect on a randomly selected day? That's what we're talking about when we're talking about the mean of this random variable t. If we put them together, how many passengers should we expect there to be? So since Pete expects 3.75, expected value, mean, same thing with these probability distributions, and Aaron expects 3.1, they together should expect 6.85. We add the two together. It's that simple. So if we're adding two random variables together, the new expected value of that sum is simply the sum of the two random variables that we added before. So it's the mean of x plus the mean of y is equal to the mean of t, also known as the expected value of t. And it doesn't matter if we're adding two random variables together or 20, we would add together all those means to get the new mean for the sum of those variables. Now we want to know, okay, that's great. We can expect on average to be 6.85. But what kind of variation is there going to be? In order to answer that question, we do have to do a little bit of work. And we actually need to find the probability distribution of t. So we're going to organize our data into a nice table, but the thing you have to know, the thing we have to pay attention to is, are these two things that we're adding together independent from each other? And with Pete and Aaron's adventures here, they are independent of each other because they're on separate sides of the country. So if we have probability models, we're really going to assume a lot of times that there is independence if it looks like they're not related to each other. So it's going to be kind of a gray area for us that we could do a little bit better job than just assuming, but for all intents and purposes, we're going to see if assuming they're independent is reasonable. And in our example with Pete and Aaron, they're on opposite sides of the country. We're going to assume that those things are independent. So we have to organize our data. We have to look at what these new probabilities and these new outcomes are. So we write down all of our x's, we write down all of our y's, and we're looking for all the possible outcomes that we could have. So x could be 2, y could be 2, so that means t would be 4. And the new probability, we're multiplying them together. The probabilities get multiplied here. What's the probability that x is 2 and y is 2? And means multiply. So 2 and 3, 2 and 4, we're going to go all the way down, and we get this new probability distribution where the probability of having 4 passengers is 0.045, the probability of having 5 passengers would be the sum of this one and that one. We're going to add some things together. We get this fairly symmetric new probability distribution for t. We're able to calculate the mean by adding, but now to get the standard deviation, we actually have to do the calculations. We have to take each t and subtract the mean. So we're going to do 4 minus 6.85 squared and then multiply by its corresponding probability. And go all the way through this probability distribution, finding the difference between the value and the mean, squaring it, multiplying by probability, and adding all of those things up. And that will give us the variance, which we can then square root to find the standard deviation. But if we compare this new variance to the variance of the individual x and y random variable, what do you notice? 1.1875, 0.89. Hopefully you're noticing that these two things added together is our new variance. And when we add two independent random variables, their variances can be just added together. The standard deviations, however, do not just add. And that's going to be a little bit counterintuitive to us because we can add the means, we can add the variances, but we can't add the standard deviations. So in general, if we have two independent random variables, x and y, and t is the sum of those two things, then the variance of t will be the sum of the variance of x and y. And that's a general statement that we can make. Remember, ladies and gentlemen, you can only add the variances if the two random variables are independent. And you can never add standard deviations. And we can go through a similar investigation with subtracting two random variables from each other, and the results are actually pretty much the same, but the order matters. With subtraction, the order does matter. If we have event D being x minus y, the expected value of D will be the mean of x minus the mean of y, same order as we're combining them together. The variance, now this might be a little bit surprising to you at first glance, the variance of our new random variable will be the sum of the old ones. Well, remember, variances are things squared. We're combining them together. Addition is like subtraction. So when we're squaring the negative, it sort of makes sense that it would end up being addition here. But in general, whether we're adding or subtracting, the variances can be added together to get the new one. So we have an example that we're going to go through, and we're going to look at how we can apply this. So we have Mr. Starn he likes sugar in his hot tea. He really likes between 8.5 and 9 grams. If it's not between there, he thinks it tastes funny, and he sends it back with the waitress. And all he has to choose from are sugar packets on the table. He happens to know, though, he's a statistics kind of guy, that the amount of sugar in a randomly selected packet is normally distributed, and the mean amount of sugar in there is 2.17 grams, and the standard deviation is 8/100ths of a gram. If this guy selects 4 packets at random, what's the probability that his tea will taste right? Okay. If we let x be the amount of sugar in a randomly selected packet, then t would be x1 plus x2 plus x3 plus x4, the sum of those 4 packets. And we're looking for what's the probability that t is between 8.5 and 9. Our average amount will be the sum of all these individual means, so 2.17 times 4. We can also add together the variances of the 4 sugar packets. Now, why are we doing this, you might ask? Well, because this is a continuous random variable, the amount of sugar, and we're looking for the probability of a range here, and it's normally distributed. To deal with the normal distribution, we need the mean and the standard deviation, ladies and gentlemen. We just found them. Well, we found the mean and the variance, but if we have the variance, we can know the standard deviation is 0.16. So mean, standard deviation, this sugar is normally distributed. Let's go. So we have this bell curve. We're looking for the area in between here and here, 8.5 and 9. We find the z-scores. We can use our table to find these probabilities, or we can use our graphing calculator to find this probability, but we find that there's an 85% chance that this guy's tea will taste right and he will not have to send it back to the kitchen. And so here is a summary of everything that we've talked about in section 6.2. You can pause and peruse this at your leisure.